Hey students, how's it going? I'm gonna show you just another example of how to graph a polynomial. Not cool. So I'm just gonna show you how I have this GeoGebra file that I have, and it helps me make these things. So what I did is I just created a quadratic function here, and then I just kind of move the vertex around until I get a you see how it spreads my zeros around like that, so I can just I can do this and it shows me what my zeros are right here, so I know they're irrational. So I'm just going to make this guy right here, this is the quadratic function right here. I'm just going to make that a factor of the polynomial, so I've got it right there, right? This is f written out in that's the quadratic written out in vertex form, so I just multiply it by a couple of linear factors. And what linear factors? Well, I don't know. Okay, why don't I make -4 also a zero of it? These are going to be zeros of the polynomial. I'll make -4 a zero, so I'll do x plus 4. And then I'll choose one over here, like how about 5 over 2? 2.5 sounds like a good zero to have. So I've already got that one in there, so okay. Now if I multiply this by those two linear factors, I get this function, right? It has the same zeros as that quadratic, but now it also hits -4 and 2.5. Alright, so this is the expanded form of the thing, and so that's how I'll start the problem. Alright, you don't see this right now, but it'll be 2x to the fourth plus 19x to the third plus 22x minus 180. 22x squared, oops, minus 133x minus 180. Okay, that's going to be kind of brutal because that's got so many different numbers in it, but that's okay. Okay, so this is the, let me turn my autofocus on here real quick. I need to turn autofocus on. There we go. Okay, so that's the one we're starting with, right? 2x to the fourth plus 19x plus 22x squared minus 133x minus 180. So I just use that GeoGebra program to build the problem for me, and now I'm going to do the problem. I'm going to graph this thing. Okay, so what do we got to do? Well, our p is going to divide -180. So there's a lot of numbers that divide that, so bear with me here. So p would be 1, -1, and then that's associated with 80 and -180. Or it's divisible by 2, half of 180 is 90. Wow, sorry. And then it's also divisible by 3. And then 180 divided by 3 is 60. It's divisible by 4 because 90 is divisible by 2. That's 45. Okay, this is getting kind of crazy. It's divisible by 5. 180 divided by 10 is 18, so doubling that's 36. Is it divisible by 6? Yes, it is. Okay, so dividing by 2 and then dividing by 3, that's 30. It's not divisible by 7, thank goodness. Is it divisible by 8? No, because 45 is not divisible by 2. Sure, it's divisible by 9, which we have not listed yet. That would be 20. Okay, it's divisible by 10. And that is, of course, is 18, -18. And then it's divisible by 12. Eventually these converge, right? 12. Okay. dividing by 12 is like dividing first by 4 and then dividing by 3. So I think we have converged on that, because 13 and 14 do not work. That's all possible values for that freaking numerator. Okay, the denominator, luckily, is going to only be 1, -1, 2, -2. So we only have to consider fractions with a denominator of 1 and 2. And the only ones that need a denominator of 2 are the odd numbers in this list. So 1/2 is so P over Q is any of these, along with fractions with odd number numerators here. So this is a really terrible example because of how many different possible things there are to check, but it's a finite list. Okay, I'm not going to check all these, but that's all of them. That's the entire list. All these and all these. So it's everything in P, because you can have divided by these numbers by 1, and then it's everything divided by 2, but the odd number ones are the only ones that give us new numbers. Okay. Fantastic. So now what? Now we just check all these. But I'm not really going to check all of them. I'm going to just keep going until, until this works out. So 19x to the third. I mean, I'm just showing you how brutal it can be sometimes to do it this way, but it does work. Minus 133x. Minus 180. Alright, now table. We got a table set. You normally don't have to do this, but the calculator resets every single time for me. Okay. 1, -1, 180, -180. We know these aren't going to work. Let's just try the smaller numbers. 2, -2. Thought that would work. Let's try 3, -3. No. 4, -4. Okay, -4 is one of the ones. Alright, I'm going to stop looking at those now, and I'm going to go to the fractions, because I think it's a fraction is my other one. Doesn't have to be, but I'm just going to systematically go through these fractions. It's kind of like a treasure hunt. It's fun. For treasure. Skipping that 45, I'm going to go over to the 5. Boom. Okay, we already knew that was going to be the case. But anyway, we found 2. It's degree 4. We can probably assume that that quadratic is going to be reducible, but even if it's not, the quadratic formula will give us the other 2, and that's probably more fun than going through this whole list anyway. We found 2. So now we do synthetic division on it to get the quadratic factor. So I'm listing every single power of x here. 2. Product of them is -8, -44. Quadrupling that would be 88. Let's go here. -133 plus 88. Okay. True. Yep. 180. Sweet. So now we hit that with a 5/2 and do it again. 2, 5, 16, 40, 18. Half of that is 9 times 45. Boom, that worked. So the way we're going to factor f is x plus 4, x minus 5 halves, and then 2x squared plus 16x plus 18. Alright, now I'm going to factor a 2 out of that and send it into that. Okay, so now we factored it. Now let's see if we can deal with this thing. We were right to not try to go any further because that does not factor. So quadratic formula will get us what we need here. So x is negative b plus or minus the square root of b squared minus 4ac all over 2a. So 64 minus 45 is 9. Okay, no, can't be right. 64 minus 45. Whoa, I am really angering myself right now. It's 19. Okay, there's nothing to simplify there. That's it. Okay, I mean, okay, you can say it's negative 4 plus or minus root 19 over 2. Okay, so those are our irrational intercepts. So what are those? X is approximately negative 4 plus root 19 over 2. So that is negative 1.82. And then if we do negative 4 minus root 19 over 2, we get negative 6.18. Alright, cool. So now we can make our table of values. So we'll do that. So how should we put this? So our other zeros were negative 4 and 5 halves, which is 2.5. So this is the smallest number that's going to show up. So I'll put that down here. The next smallest one is negative 4. The next smallest one is negative 1.82. Then we want the y-intercept. And then we want this other 0. So I'm going to choose some other numbers in these ranges just so I can fill this guy out. You're doing it good. How about negative? It's almost negative 2, so I'm going to go with negative 3. Negative 1 is in between them. About 1. Okay. That's good. So let's go back to our table. I'm not going to just delete all these. I'm just going to overwrite them. So 3, 2.5, 1, 0, negative 1, negative 1.82. I'm just going to do negative 4 plus square root of 19 over 2. That didn't work. There's something wrong. That's good, though. That's not necessarily a bad thing. What happened here? 2, 16, 18. Factored out the 2. So I'm thinking that's right. Okay, so negative b plus or minus b squared minus 4 times a times c. That's where I said that was 45, but that's 36. So, okay, I mean, that's why you want to put these numbers in here. It's 64 minus 36. Which is 28. Okay. So 28, 4 comes out, so that's negative 8 plus or minus 2 root 7 over 2, so it's negative 4 plus or minus root 7. Okay, so what are those? Negative 4 plus, dang it, negative 4 plus the square root of 7. So we are getting x is negative 1.35 approximately, and then x is approximately negative 4 minus the square root of 7. So it's not bad that that happened. I mean, I made a mistake, but we caught it because we were being careful when we put these in the table. Now, so our other numbers are still valid. So let's just change these. So negative 1.82, it's negative 1.35. So luckily that worked. So it's still in between them, and it's a nice, it works nicely. The negative 6.65, yeah, this is just fine. Nothing's messed up here. Good, so let's go back to the table, and now it should work. So the error happened right here. So instead it's negative 4 plus root 7, so this is, just check it again. Yep, good. So let's write these in there. 294, 0, negative 270. The y-intercept is negative 180. Negative 1 gave us negative 42. This was our 0. Okay, negative 3, negative 4, negative 5. Then our other y-intercept is negative 4 minus the square root of 7. Good. And then negative 7. So negative 3 gave us 66. Negative 4 was a 0. Negative 5 was negative 90. This was also a 0, and then 114. Good. So the biggest number in the table is right here, and the most negative number is this one. So that's telling us how to scale that. Negative 300 to 300 should do it. Okay, so scale our x-axis, negative 8, negative 6, negative 4, negative 2, y-axis, 2, 4. That's going to work there. And then, like I said, negative 300 to 300, so 100, 200, 300, negative 100, negative 200, negative 300. That window will work pretty well for us. Okay. So I'll start over here. 294. Just about right there. 2.5, 0. 1, negative 270. So that's like there. Negative. Oh, well, they were slightly out of order. Oh, wait a minute. Yeah, no, this is right. Then 0, negative 180. Then negative 1, negative 42. Then the 0 was at negative 1.35, so right there. Negative 3 gave us 66, so that's 2/3 of the way up here. Negative 4 is a 0. Negative 5 is a negative 90, so it's almost down to negative 100. Negative 6 2/3 gives us a 0. And then negative 7 gives 114. Alright, so it's looking like what's happening here is this is going to do this. So let's see. Negative 8 to 4. Scaling by 2. Negative 300 to 300. Scaling by hundos. Graph. Looks good to me. So, thanks for watching.